class. Today we're going to be talking about section 10.3, which is the parabola. So this type of parabola is going to be a little different than the one you've seen before. We are in our conics sections chapter, so we're going to be looking at parabolas that open up and down like we've seen before, but also parabolas that open to the side. And graphing them, we're going to do it a little differently than we've done before, actually very differently than we've done before. But it'll go along with what we've been learning in this conics chapter. So first, let's look at the standard form equation for a parabola with a vertex at hk. So this is going to be different than the parabolas we've seen before. We have two different types of equations depending on whether it opens horizontally or vertically. A parabola, so let's think, just to review. If you think about the parabola that you've learned before, it was just y equals x squared or transformations of that, and this thing looked like this. So when the x is squared, you're going to have a parabola that opens up or down, or it opens vertically. If the y is squared instead of the x, then we're going to have a parabola that opens horizontally. And students tend to get this mixed up when we get to this section because they think, oh, x squared, so x is horizontal, so it opens horizontally. That's not how it works. It's backwards. So just try to remember back to our previous courses where you did your y equals x squared. That was a parabola that opened up and the x was squared. So that's how I kind of remind myself which way it's going to open. Now, these equations are going to be a little different than the ones we've seen in the last few lessons, which were circles, ellipses, and hyperbolas. All three of those types of conic sections have both x squareds and y squareds. But with a parabola, only one of our variables is going to be squared. So we're going to have to do a lot of work here that's a little different. But when we complete the square at the end of today's lesson, we only do it for the variable, one of the variables, whichever one has a squared piece to it. A vertex is at hk, just like it has been before. H is always next to the x value. K is next to the y value, and then you have to switch the signs for those. The focus, we are going to do the focus. We're going to be using a p-value. We haven't really done anything with the focus in the last few lessons, but here we're really going to use that to get the points to graph our parabola. So we're going to be looking at this 4p part of our equation to get the value for p, and then use the graph to figure out where the focus, the point, coordinate point for the focus is. We're not really going to look at the directrix too much. In this course, you'll look at it more if you go into pre-calc. And then for the how it opens, so right or left is going to be the negative direction. So if our p-value is negative, we'll go to the left. If it's up or down, again, down is that negative direction. So if we have a negative p, then we're going to be going down depending on which variable is squared. All right, so let's look at, actually, let's go back up here really quick. I just want to make a note that this value here is p. And then to get 2 more points, what we're going to do, and it doesn't show it on here, but what we're going to do is get this point and this point, which is going to be 2p away from the focus. So even this direction, so this here is our p distance, and from here to the point on our parabola, the parabola kept going, and from here to there, this is going to be 2p. So we're going to use that focus, the p-value, to get the focus, but also to get 2 more points on our parabola to figure out how wide it opens. So how to graph a parabola from this type of standard form, the first step we're going to do is find the vertex. So let's look at this example, our vertex. So we look at what number is next to the x value, we change its sign, and the number next to the y value, we change its sign. So in this example, we're going to have positive 3, negative 1. So positive 3, negative 1 goes here. Now we're going to determine if the parabola opens up or down or right or left. And we're going to be doing that based on which variable is squared. And then if the p value, or that 4p part, is negative. So here the x is squared. So I want you to think y equals x squared. Back in the day, that's a familiar equation for us. Those parabolas opened up or down. And then this one here, p is positive, so it's going to open up. Now to find the focus, we're going to use the graph. The focus is a coordinate point. So I'm going to set up a coordinate point so I don't forget. But in order to do that, I'm going to set this part, and let me highlight it here. This part here is equal to 4p. So if you look back up at our equation at the beginning, that piece there is equal to 4p. We're going to use that to figure out the focus. So we set 4p equal to 8. So I'm going to highlight this here so we can kind of see where that's coming from. So 4p equals 8, and it's just part of the equation. You're just going to have to memorize it. You might say, well, why is it 4p? Just that's the way the math works out. So there you go. If I divide by 4, I get p equals 2. Now, because it opens up, I'm going to go up 2 from my vertex. So if this is my vertex, I'm going to go up 2, and that's going to be my focus. That coordinate, the coordinate at 3, +1 is my focus. Now I know the parabola opens up from the vertex, but I don't know how wide or narrow it is. So to do that, I'm going to use 2p. So 2 times 2 is 4, and I'm going to go 4 in the direction, like if you think about drawing your parabola, I need to go sideways for my focus. So 1, 2, 3, 4, kind of 3, 4. Ran out of room there. And then 1, 2, 3, 4. And that's how wide my parabola is in this problem. All right, and that's all we need to graph our parabolas in this type of form. So let's look at example B. We have a y squared this time. So if we think y squared equals x, that does not feel familiar. That shouldn't feel familiar to you. So this is going to be the weird parabola that opens sideways. Whoops. And since this value here is greater than 0, then it's going to open positive in the sideways, so right. Instead of right or left, it's going to open right. Our vertex, remember the x value, opposite sign is -4. Y value, opposite sign is -1. 1, 2, 3, 4, 1. All right, -4, -1. Make sure to number at least one piece of your axes so I know what you're counting by. It opens to the right. I'm going to set 4p equal to 12. My focus is a coordinate point. Remember, I'm not trying to find p, I'm trying to find the coordinate of the focus. So divide by 4, and p is 3. So now I'm going to go to the right 3, since it opens to the right. 1, 2, 3. That's my focus. This one's my vertex. Now it opens to the right. So now I'm going to take 2p, which is 8, and I'm going to go 8. If we think about how that's going to open to the right, 8 up and down from our focus. So 1, 2, 3, 4, 5, 6, 7, 8. Keep running off my graph here. And 1, 2, 3, 4, 5, 6, 7, 8. It's just, my graph was not big enough. All right, and then we graph that. And this way. That is a very wide parabola. The focus, oops, I forgot to write it in. It's so easy to forget. It was at -1, -1. All right. Oops. I made a mistake. Oh my goodness. Okay, going back. I was wondering why it was so wide. 4, gosh, 12 divided by 4 is 3. I'm going to fix this. 3. 1, 2, 3. I went 3 to the right, and then I wrote 4, and I messed it all up. So 2 times 3 is 6. Not quite as far. 1, 2, 3, 4, 5, 6. That's better. 1, 2, 3, 4, 5, 6. So still runs off my graph, but not as badly. Oops. We all make mistakes. It's okay, as long as we learn from our mistakes. Okay, there we go. That's better. All right, next page. So we have a couple more examples here. These are really new, so it does take some time to get used to these. So y is squared. My vertex is 2, -3. And you might want to pause the video at this point and see if you can do it. The only new thing here, whoops. The only new thing in this example is that p is less than 0. It's negative, so it's going to open in the negative direction. But you can pause the video and see how you do. All right, so we have a vertex of 2, -3, and the y is squared, so that's the weird one. It's going to open sideways, and it's going to open to the left because my p is negative. All right, the focus is a coordinate point. 4p equals -4. P is -1. So I'm going to go, let's see, vertex at 2, -3. 2, -3. There's my vertex. I'm going to go to the left 1 for my focus. So that's going to be at 1, -3. Then 2p is going to equal, 2, -2. So I'm going to go up 2 and down 2 from my focus to get my points for the parabola. Be careful, make sure it doesn't look like a line. We want it to look nice and curved like a parabola. All right, and then the last one, part B, my vertex. Again, you can pause the video and see how you do. We've got 2, -1, so the x part first, y part second. The x is squared, so that opens up or down. P is negative, so it's going to go down. My focus is a coordinate point. 4p equals -4, so p is -1. So I'm going to go down 1 from my vertex. So 2, -1. I'm going to go down 1. There's my focus. Vertex. So focus is at 2, -2. And then 2p is -2. So I'm going to go over 2 from my focus sideways so I can get my curve. And that one didn't go through quite as well as I wanted it to. There we go. All right. And there's that last graph example. All right, so now let's look at converting the equation by completing the square so we can get it into this graphing form. And I'll do both of these examples. So first, we want to look at which variable is squared. So in part A, our variable y is squared. So what I want to do first is isolate the variable that's squared, but like all of those pieces. So y squared plus 2y equals, and then move the other ones over. So I'm going to subtract 12x. Remember, when it crosses an equal sign, it changes signs. I'm going to add 23. Now what I want to do is I want to complete the square. So y squared plus 2y plus what will give me a perfect square. But I'm not just allowed to add anything I want. I need to balance that out. We've done this a lot in this chapter. 2 divided by 2 squared is 1 squared, which is 1. Now, if you're looking at this video and you are taking like Algebra 1 or maybe an Algebra 2 course and you've never seen something like this, chances are you're supposed to be graphing your parabola in a different way. This is just kind of a specific way to do it if we're in conic sections, especially when we've got a y squared instead of an x squared. So just an FYI, there are other ways to graph parabolas. All right, and then so I'm adding 1 to this side. I need to add 1 to this side to balance it out. Y plus 1 squared equals -12x plus 24. Now, if we think about our general, or sorry, not general, our standard form of our equation, let's look up here. Standard form, I'm going to have y minus k squared equals 4p times x minus h. Notice we have to have something times that x value or quantity x minus h. So if there's a number in front of x, we need to factor it out. Y plus 1 squared equals, I'm going to factor that -12 out. X minus 2, factoring out a negative changes the sign. And there is my standard form equation. All right, let's do one more example. Of course, you can pause the video and see how you do. All right, so we've got x's are squared this time, x squared plus 8x. And then I'm going to move the y piece over, so positive 4y. I'm going to move the 8 over, -8. X squared plus 8x plus what will complete the square? 4y minus 8 plus blank to balance it out. Completing the square, 8 divided by 2 squared, which is 4 squared, which is 16. And add it to both of those pieces to balance this out. Now I've completed my square. If I factor x squared plus 8x plus 16, I get x plus 4 squared equals 4y plus 8. I just need to factor out the number in front of the y. Be careful, make sure you actually factor it out of that 8 as well. And I am done. All right, and that is it for today's lesson.